Hello my friends and welcome back to the You Can Do TV channel.
Despite being pushed into position under an active rail corridor, the new underbridge at Osborstown still holds its exact geometry, giving crews a target that must land perfectly across the weekend operation. The project focuses on installing the road bypass structure built by Sisk and Ironrod Erin, set beside the Cork-Dublin line months in advance and prepared for a tight Easter window. Crews gather around the precast sections as large movers guide each part into sequence, and that scale shift always feels like groundwork turning into momentum fast. The coordination between transporters and riggers here shows how precise planning reduces margin for error. The opening action brings heavy plant forward to expose the track bed so the old formation can be lifted out without disrupting the wider corridor more than necessary. As the ballast is cleared, steel frames built earlier help stabilize the work zone. You notice how the team rotates tasks quickly, and that pace might catch you off guard if you're used to slower civil jobs. The first assembled section is maneuvered using multi-axle transporters, with operators adjusting angles to keep stress off the edges. Another segment follows, locking into place through guiding pins that had been prepared during the prefabrication phase. Feels like the structure wants to sit exactly where the crews aim it, creating a moment where movements look almost cooperative. Seeing the prefabricated unit slide seamlessly into place highlights the benefit of pre-assembly for tight weekend schedules. Hydraulic jacks raise each segment so shims and bearings can be inserted, delivering the required road clearance below. A quick concrete pour secures the shoulders, and reinforcement cages tie into previously placed housings. Someone following the job might think the whole build moves quicker than expected, almost like the machine lineup refuses to slow down once everything aligns. The assembled underbridge is then pushed fully into its final channel, sliding across low-friction plates laid down earlier. The way these plates reduce friction allows heavier sections to move with minimal force, a subtle but critical efficiency. Once seated, crews rebuild the rail formation above. New ballast is placed in layered passes, tamped to achieve the target level. The track panels return next, locked by clips that crews check in rapid sweeps. You might find the contrast interesting between the massive lift earlier and the quiet precision of restoring the line, a shift that feels like heavy force, giving way to controlled finishing moves. Lighting rigs cover the site through the night as drainage channels connect to the new structure. Road approaches on both sides are graded, compacted, and sealed so traffic can shift onto the new bypass soon after rail service resumes. By the time the final inspection wraps up, the underbridge stands ready beneath the corridor, its weekend installation sequence turning months of preparation into a single coordinated push for the crews. Built to resist pressure yet still yielding when the crane at the site guides them, these precast panels show a firm but flex dynamic. The sequence focuses on installing these concrete panels with a mobile crane guiding every shift. A quick glance at the lift already shows how the load behaves, and that sway feels like a reminder that machines still negotiate with gravity. The way sparks fly during alignment highlights the precision needed to avoid any misfit. Crew members attach lifting points so the crane can take up tension and raise the panel toward its footing. As the panel nears its slot, guiding lines help control its path, and that tiny lean during the move almost looks like the panel is testing everyone's nerves. Some viewers might react the same way on first seeing it, and that moment when it hovers just inches from the supports feels like holding controlled power in motion. Once the bottom edge approaches the dowels, operators ease the crane so the panel can settle onto its supports. Braces are then brought in to hold the piece steady. That steady lock-in looks stronger than you predict from something moving just moments earlier. The braces create a stable triangle so the panel won't drift. Watching the crew check alignment repeatedly shows how small adjustments make a huge difference in large-scale lifts. After the geometry is set, workers secure the braces to anchor points and verify plumb lines. Connections are reinforced as needed, and the crane releases tension so the panel stands independently. Further checks confirm the surface line and joint spacing. Sealants or temporary fillers are added depending on the project phase. Cables are gathered, and the team transitions to the next unit, repeating the controlled sequence. Somehow the whole lift and set cycle feels smoother than you'd expect for concrete this large. Bridges spanning the Chiltern Twin track at Bicester rise in careful sequence over a 100-hour Easter blockade. Story contracting positions each precast underbridge section with multi-axle transporters, ensuring every piece aligns to the exact footprint planned by Network Rail and Oxfordshire County Council. The controlled lifts show how heavy units can move smoothly when planning and machinery sync perfectly. Temporary supports brace the spans as connections are adjusted, dowels aligned, and panels guided into slots. Pedestrian tunnel units follow a similar sequence, slotting precisely into place without delay. Teams run verification checks at each step, confirming levels and alignment. Seeing the underbridges lock into place in hours instead of days highlights the efficiency gained by prefabrication. With spans stable, attention shifts to finishing works and clearing the site for traffic. The speed of the operation almost makes the concrete sections seem nimble. Follow the careful alignment as massive pre-stressed concrete bridge beams are positioned over the CSX Railroad near Sydney, OH. J Crane brings 175-ton and 100-ton cranes into play, maneuvering each beam with precision across the active tracks. The rigging points are engineered to handle dynamic loads safely. Spotters guide each lift, ensuring the beams clear all obstacles while staying level, a task that requires constant vigilance. Load readings are monitored in real time to prevent unexpected shifts. Transporters deliver beams to staging areas where crews prepare rigging points. Chains and clamps are inspected before every lift to guarantee structural integrity. Beam placement tolerances are within millimeters, reflecting careful planning. Watching how the beam hovers mid-air while the crew makes subtle adjustments really highlights teamwork and engineering skill. As the crane lifts the first beam, temporary supports are ready to receive it, preventing any stress from transferring to the rail below. Alignment pins and shim plates guide the beam into exact placement, with the operators easing the load slowly. Shim plates are adjusted incrementally to achieve exact leveling. Spotters communicate continuously, coordinating minor corrections with precision. Each subsequent beam follows the same sequence, stacked in planned order for efficiency. Teams rotate between guiding the lift, securing temporary bracing, and confirming level and plumb. Hydraulic jacks are used selectively for small alignment corrections. That coordination feels like muscle and intelligence packed together, especially under the time pressure of an active railroad. Spotters double-check clearances and communicate minute adjustments to the crane operator, a rhythm of trust and precision that's crucial for safety. Final inspections verify anchorage points before releasing any rigging. Once the beams are seated, crews fasten connections and check anchor points. Additional braces ensure lateral stability, while final inspections confirm tolerances. The cranes are moved in sequence to avoid obstructing the remaining lifts. Small corrections are made with hydraulic jacks where necessary, and the rigging is gradually released so each beam carries its own weight. Safety zones are maintained throughout the operation to protect all crew members. Seeing the massive beams lock in place without any visible movement gives a surprising sense of quiet strength. Once the final beam is set, the cranes are repositioned, the site cleared, and the railroad resumes normal operation. The entire process condenses complex engineering and careful logistics into an elegant sequence that seems effortless from the outside. A long turnout is carefully positioned along the LGV Breton Pays de la Loire line, with PEM-LEM machines orchestrating each movement. The turnout spans 150 meters, split into two precise sections that demand flawless coordination. PEM gantries, radio-controlled, hover over the new track, maintaining stability while automatically leveling the turnout. LEM self-propelled trolleys transport each section under controlled speed, guided by a single operator with radio control. Hydrostatic transmissions and brakes keep every move smooth and predictable. Staging areas allow PEM units to collect and prepare sections for installation. Each gantry can work independently or in synchronization with others, keeping all loads stable during lifts. Inclinometers on the PEM monitor tilt, ensuring the turnout is perfectly leveled before placement. Operators adjust movements gradually, lining up the turnout to the auxiliary runway that serves as a temporary support. 3 operators manage 16 gantries, a combination that feels like a human-machine relay in real time. Once aligned, the LEM trolleys move sections along the auxiliary runway, carefully slewing them into their final positions. The controlled slewing prevents any stress on the track or turnout components. After the sections are seated, the auxiliary runway is removed, leaving the turnout fully installed. PEM gantries then return to their collecting area, preparing for the next operation. The entire 150-meter turnout is laid in about 5 hours, a testament to synchronization and radio-controlled efficiency. It's almost funny how calm the operators look while orchestrating such a heavy and precise sequence. You could easily imagine the machines and humans silently competing for perfect alignment. The turnout now sits ready, connecting new track sections with millimeter-level accuracy, and the PEMLEM system exemplifies the blend of automated technology and operator skill on high-speed lines. Concrete placement on highways sometimes feels unusual because the slip-form paver at this project spreads material in a wide sheet that looks seamless. Operators guide the paver forward to shape the fresh concrete, and that steady push feels like controlled muscle moving along the grade. The crew positions rails and sensors to keep thickness consistent, and you might catch yourself thinking the glide is smoother than expected for wet concrete. Vibrators consolidate the mix, reducing voids before the screed levels the surface. That sweep across the top almost resembles a calm swipe despite the weight involved. Finishing arms tidy the edges to keep the slab uniform. The long pass somehow feels patient, even though the machine covers ground quickly. Its consistency helps maintain long-term durability today overall. Gulf precast panels create a villa superstructure that rises with solid geometry and dependable fit. Each segment is lifted onto connectors, and that snap of alignment feels unexpectedly neat. Crews secure joints so the walls lock firmly. The floor planks dropped in so cleanly. Panels for upper levels follow, stacked along the grid. Bracing keeps everything stable until the structure stands on its own, and the pace almost reminds you of building a life-size kit right here. Even though some beams are difficult to handle, they are staged flat, yet maintain perfect alignment for lifts. Each beam section contributes to a room-attached assembly that stretches across the workshop floor. Jigs and temporary supports hold beams in place as sections are aligned, ensuring subsequent lifts will be precise. Flat staging allows teams to monitor multiple units at once, improving coordination. The flat layout accelerates the workflow, avoiding bottlenecks in a confined space. Operators prepare each beam with connection plates and inserts that lock into corresponding slots. As sections slide into place, crews check levels and plumb, making minor adjustments to guarantee uniformity. Alignment pins are double-checked before lifting to avoid misplacement that could affect the entire assembly. Load readings are monitored at each step to prevent uneven stress across the beams. The coordination between machine handling and manual guidance makes the large structure feel almost light. Hydraulic trolleys lift pre-assembled units while spotters verify alignment, preventing stress concentrations that could compromise the geometry. Those end beams really test patience, yet the team moves them without hesitation. Temporary supports are adjusted continuously to maintain exact horizontal and vertical positioning. The sequence of lifting is planned to minimize potential collisions and interferences on the floor. Once lifted, sections are bolted into the main assembly, and temporary braces are removed gradually. The careful sequencing lets multiple crews operate simultaneously without interference. Minor checks on bolts, shims, and bearing plates confirm each part carries weight evenly. Final alignment measurements ensure all units are plumb and level before the floor assembly is cleared. When all beams are in place, finishing inserts secure joints, and the floor assembly is inspected one last time. Seeing a full room-attached unit come together on the ground feels almost like watching a giant puzzle solve itself. By the end, the assembly stands complete, combining months of pre-planning and precise coordination. The efficiency here highlights how practical staging can optimize even the most complex layouts. Each completed unit is ready for lifting and final installation, showing the balance of human skill and mechanical assistance.
Balancing on a steep hillside, the Menzie Muck A91 navigates vineyard terraces with remarkable agility. Its power tilt and normal bucket allow precise soil shaping without repositioning the entire machine. Operators adjust the outriggers carefully to maintain stability while digging or moving materials. The combination of hydraulics and articulated joints keeps the machine level even on extreme slopes. Checking load distribution continuously prevents tipping and protects the hillside. Each bucket movement is coordinated with the slope angle, minimizing soil disturbance and optimizing planting rows. The A91's ability to move sideways without losing traction saves both time and effort in uneven terrain. Operators can switch between power tilt and normal bucket quickly, adapting to different tasks from trenching to leveling terraces. Auxiliary sensors provide real-time feedback on tilt and extension, improving safety and efficiency. Adjustments are made in small increments, ensuring that vine rows remain straight and uniform. It's surprising how smoothly the A91 handles inclines that would challenge conventional excavators. By the end of the day, multiple terraces are shaped precisely, combining human skill and the machine's versatile capabilities. The vineyard benefits from consistent terrain preparation, while operators maintain control over every movement.
Deep mud can turn a routine field job into a full-scale struggle, and the New Holland TM120 proves that the moment its rear tires sink almost completely out of sight. The tractor enters the patch with its plow still attached, but the ground is too soft, locking the wheels in place before it can gain any meaningful traction. To get it moving again, the operator connects a heavy chain to a John Deere 6420, hoping the combined pull will free the TM120. Both drivers coordinate their throttle inputs, trying to match speed and tension so the chain stays steady. The John Deere pulls forward, its engine delivering steady torque, while the TM120 attempts to crawl out of the rut. Even with both machines working together, the wheels keep spinning in place. The TM120 twitches sideways like it wants to escape on its own, but the reality is clear: this mud is deep. The mud keeps swallowing the tires. You can almost feel the frustration when both tractors strain yet barely move an inch.
Operators lift and unfold mobile stage arc quickly, each movement calculated to ensure speed and safety. Its modular frame allows the stage to extend quickly, letting crews configure performance areas with minimal effort. Every hinge and locking mechanism is engineered to ensure safety without slowing setup. The trailer's hydraulic lift smoothly elevates the roof while side panels unfold, creating a versatile performance space. It's surprising how much stability the lightweight aluminum structure provides. Operators guide the stage into position, checking alignment and leveling for uneven ground. Steel supports lock into place as the platform reaches its full height. Even with a single person handling controls, the system reacts predictably and efficiently. Work continues seamlessly as additional panels slide into position, forming protective roofing and sidewalls that shield performers and equipment. Temporary guardrails click into place, adding security for artists and staff. The curved roof not only provides aesthetic appeal, but channels rainwater effectively during outdoor events. With the mobile stage arc fully deployed, lighting rigs and sound systems can be mounted rapidly. Crew members move around the perimeter, adjusting braces and checking all locking pins. The compact trailer design means transport between venues is simple, avoiding complicated logistics. Finally, the stage is ready for a concert, conference, or festival, combining speed, safety, and functional design in a mobile package. Hard to imagine a full stage assembly happening this smoothly in under 35 minutes.
Thames Tideway Tunnel intercepts untreated sewage spilling into the Thames to protect the river and improve London's environment. "430-meter shafts being bored deep beneath the Swiss Alps for the pumped storage plant at Nantes-de-Drance form the core passages that will guide water toward 900 megawatts of clean energy. Drilling rigs line the mountain's flank while crews steer giant drill heads downward, carving circular tunnels built to withstand immense pressure. After 8 months of continuous advance, the second shaft reached 245 meters below the surface. 2 months later, rock and earth gave way further, 298.5 meters, and still descending. That depth climbs faster than you expect once the cutters find the right layer. Concrete lining sections followed, each locked together to resist heavy hydrostatic force. Over 2 years of tunneling and lining, the team completed both shafts to their full depth of 430 meters. Control rooms, pressure valves, and safety sensors now stand in place, securing years of underground work behind reinforced walls. Feels like every meter drilled shows how much coordination these crews handle daily. Finally, once the gates open, turbines at Nantes-de-Drance will surge to life and power hundreds of thousands of homes. Can't believe how water will shoot through those tunnels with that much power. Feels like the mountain just turned into a giant battery for Switzerland.
The H-25 IVC rumbles across the A-44 construction site, crushing massive rocks under 150 heavy-duty picks. Each strike crushes boulders that could easily block conventional machinery. It is engineered to endure extreme stress, allowing continuous operation. Operators guide the machine over uneven terrain, watching the hydraulic arms adjust to maintain consistent pressure. That crushing power looks effortless while handling stones. The fragmented rock is immediately compacted by the roller, producing a stable base for future paving. Skilled drivers control speed, angle, and pressure as the H-25 IVC methodically processes each section of the construction site. Sensors monitor machine performance, ensuring each hammering cycle is optimized without overloading components. Crew members communicate continuously to maintain alignment and safety, coordinating with surrounding vehicles and staff. The efficiency is remarkable for a single machine managing both braking and compaction tasks. Occasionally, the machine pauses mid-path to reposition on steeper slopes, a subtle reminder of the precision required. Even massive meter-sized boulders are reduced to uniform aggregate suitable for immediate layering. Feels like watching controlled chaos become ordered efficiency. Over several hours, large rock obstacles are reduced, compacted, and prepared for the next stage of highway construction, demonstrating the combination of engineering, technology, and operator skill. The integrated tool-changing system allows rapid swaps between picks and rollers, keeping downtime minimal. The machine truly turns tough terrain into a manageable foundation. The machine's consistent output reduces the need for additional manual labor on site. The KEMROC Cut and Break C&B system tackles hard rock in areas too sensitive for blasting. Its design allows for controlled stress relief, preventing sudden fractures in large blocks. Operators guide the machine as it cuts precise slots into the stone, reducing internal stress before breaking. ADMW cutter wheel slices through thick layers, creating controlled points for the subsequent break. You can almost see the tension in the rock relax after each slot is cut. That first cut can feel like opening a locked door to the rock's inner structure. Once slots are prepared, the C&B tool, bucket, or ripping tooth applies targeted force, splitting the rock into manageable pieces. Each movement is calculated to prevent excessive vibration, ideal for urban sites or delicate foundations. Even tricky angles can be managed with the hydraulic arm's fine adjustments. Skilled operators monitor pressure, speed, and alignment as the machine advances, adjusting hydraulic arms to maintain consistent contact. Operators often switch between cutters and breakers mid-cycle, keeping work efficient. Switching between tools is seamless, allowing crews to adapt instantly to different rock types or braking requirements. Material removal is staged methodically, ensuring a clear path for the next cut and break cycle. Strategic sequencing of cuts maximizes efficiency while minimizing downtime. Feels like the rock itself is cooperating, giving way under strategic pressure. Safety teams observe from a distance, coordinating with the operator to confirm every cut and break stays within planned tolerances. Communication is key, and radios keep everyone in sync. The technology shines on quarry and demolition projects where drilling or blasting would be disruptive or prohibited. Slots created by the DMW cutter wheel act as stress relievers, preventing unpredictable fractures. Large sections can be removed without risking surrounding structures. It's surprising how controlled the process is, given the sheer size of some rock blocks. After each cut, the C&B tool applies precise impact, cracking the material without disturbing surrounding structures. Dust suppression and debris collection systems keep the workspace clean. By the end of the operation, large stone sections are reduced, sorted, and ready for removal, all achieved without explosives. Even heavy debris moves smoothly once pre-cut slots are applied. Efficiency, control, and adaptability define the cut and break method. This method turns heavy, unyielding rock into usable pieces with minimal risk and disruption. Engineers and operators work in tandem, ensuring that each section is treated consistently, demonstrating that smart engineering can replace traditional heavy-handed methods. Honestly, seeing rock split so predictably still makes you blink twice. The system proves that precision cutting and controlled breaking can accomplish what was once only possible with vibration-heavy techniques. It's a method that balances brute strength with fine. Haul trucks transport coal across steep mining levels while maintaining precise load balance. Each loader carefully scoops heavy chunks, tilting and lifting with balanced force to avoid spillage. Operators judge the weight and center of gravity instinctively, ensuring the machine remains stable. Trucks receive the load and adjust suspension automatically to handle sudden weight changes. Once loaded, trucks follow a planned route toward a staging area, climbing slight inclines and negotiating turns while carrying their heavy cargo. Even small errors in path selection could affect timing or safety, so spotters constantly guide the drivers. At the dump point, trucks tilt their beds to deposit material onto a slope or stockpile, preparing it for the next phase of processing or transport. Loaders may reposition to gather more from the original pile, maintaining continuous workflow. The operation feels like a mechanical relay, each vehicle passing the baton smoothly. Efficiency relies on coordination, load management, and careful timing. Dust suppression and debris control ensure minimal environmental impact. By the end of a cycle, hundreds of tons of material are moved systematically, proving that well-managed equipment can replace brute force with intelligence and planning. Engineers and dock crews align Allure of the Seas in the dry dock at Navantia, Cadiz, to start maintenance work. Dock crews ensure the vessel is perfectly leveled to prevent structural stress during work. Cranes and scaffolding are positioned strategically to provide access to all decks and hull sections. Technicians inspect hull plating, identify corrosion, and remove worn components with precision. Hydraulic lifts adjust platforms so teams can reach every angle safely, while piping systems are drained and cleaned for servicing. Electrical crews trace circuits and verify connections before components are reinstalled. All fasteners and seals are double-checked to maintain watertight integrity. Painting and coating teams follow, applying protective layers to preserve the hull against saltwater exposure. Machinery in the engine room undergoes inspection, lubrication, and parts replacement as needed. It's impressive how coordinated everyone moves across such a vast ship, without interfering with each other. By the end of the schedule, the Allure of the Seas is restored, ready to sail again under Royal Caribbean. Rows of unit carriers NUC-2500 move steadily across the machinery center at Uchimiya Transport Machinery Company Limited. Each carrier moves in perfect formation, avoiding collisions even at tight turns. Operators guide the vehicles through the pathways, coordinating movements carefully to avoid obstacles. Each carrier carries its load methodically from one station to the next. The efficiency here shows how organized internal transport can streamline production logistics. The synchronized operation ensures each section reaches its destination efficiently.
Steel, fire, and skill converge in this workshop as standard Volvo steelies are transformed into wider, more robust rims through precise welding. Starting at 6 inches, each wheel is extended to 9 and 9.5 inches, improving both stance and performance for the trucks. Seeing the sparks fly while the rim stretches under careful hands makes you pay attention to every movement. Operators clean and bevel the rim edges, preparing for the extension piece to fit seamlessly. Grinding the edges before welding ensures a strong bond without gaps. The grinder's feed rate is adjusted to match the new metal density for smooth blending. Next, the welder applies bead after bead, gradually attaching the extension. The heat at the weld looks intense, and it clearly takes control to handle it safely. A quick visual check after each bead confirms the rim remains true to its shape. Careful control of the flame prevents warping, while continuous measurement ensures the rim widens evenly all around. You'd never think a few minutes of welding could reshape heavy steel so consistently. The thickness of the added metal is constantly monitored to match the original wheel strength. The angles of the welds are adjusted to prevent any mismatch along the rim circumference. After welding, the wheel cools slowly to relieve internal stresses. Each wheel is carefully inspected to confirm no cracks or imperfections remain. That small weld extension really changes the look and feel of the wheel. Once inspected, the steelies are ready for tires, improving stability and appearance on Volvo trucks. Measuring concentricity after finishing ensures the wheel rotates without vibration. It's amusing how a few inches can give the whole wheel a new character. Throughout the process, human skill and careful welding combine efficiently. The hands, tools, and controlled heat work together to create steelies that are functional, durable, and visually enhanced. Every step, from securing the wheel, welding, cooling, grinding, polishing, to final inspection, requires attention and patience. The tip of the welder sometimes seems like it's drawing the wheel into shape on its own. From start to finish, ordinary steel wheels are transformed into widened, high-performance components ready to enhance Volvo vehicles. Each rim reflects careful technique, attention to detail, and the craftsmanship embedded in industrial metalwork. Nails take shape under the precise guidance of machines and operators at Wuxi Longting Machinery Factory. Each coil of steel wire is drawn through the LW-type pulley wire drawing machine, reducing its diameter while increasing tensile strength. The continuous drawing process ensures uniformity in every length of wire, ready for high-speed nail production. Wire rolls are then straightened and fed into automated nail-making machines, including the LT4D high-speed low-noise automatic nail-making machine, designed for various nail types from roofing to U-shaped nails. Every nail is formed with exact dimensions, thanks to synchronized punching and cutting mechanisms. The machines apply compression and shaping forces at controlled speeds, producing nails with consistent length and diameter. Vibratory feeders organize nails for packaging, while air compressors maintain steady pressure to optimize machine performance. It's easy to underestimate how efficiently these machines turn raw wire into hundreds of nails per minute. For coated nails, Otto's small hardware painting machines apply epoxy paint with hardener. Heat curing ensures durability and resistance against corrosion. Operators check quality visually and with simple gauges to catch any deviations. Even small adjustments in wire tension or paint flow can impact the final product significantly. Finished nails are counted, bundled, and packed according to specification before shipment to international markets. Feels like this setup could run non-stop and still keep perfect output. The combination of human oversight and automated precision keeps Longting nails competitive globally. That speed alone could catch anyone off guard the first time. Built for force that solves tough jobs, the Brock 800 at SSAB shows how a remote-controlled machine restores a ladle mouth so steelmaking can keep moving. Its ability to stay stable under repeated impact stands out immediately. Its reach and controlled strikes give operators a tool built for situations that overwhelm regular equipment, and someone watching this might just blurt out a quick "wow" without thinking. Moments like the first heavy strike remind you why remote operation matters. Once the machine positions itself, work shifts to the scraping tool. Instead of scraping or chiseling by hand, the Brock 800 uses firm prying force to break away the hardened slag attached to the ladle mouth. The scraper's consistency helps keep the cleanup predictable. This part almost feels like the machine is saying, "Step aside, I've got this." Each push snaps material loose in chunks that fall safely away from the opening. Its arm adjusts with steady motion, while the tool pries off the last pieces that restrict metal flow in the next pour. Kind of wild to imagine doing this manually when a remote operator can stay at a safe distance and still get full power on target. A lot of crews probably wish every tough cleanup job had a machine like this. A quick "that went faster than expected" fits this moment well because the machine turns a demanding maintenance chore into something more controlled and predictable. Seeing the ladle ready again so quickly explains why this machine is used in so many plants. Every stroke of the Arisa 630-ton press moves steel and aluminum forward with controlled force, letting Kovmec handle serial stamping at scale. The line works with materials up to 6 millimeters thick, shaped through progressive and transfer tooling to meet high-volume needs. This capacity is exactly why the setup can handle both aluminum and steel without switching main equipment. How fast these machines move, but that speed fits the demands of serial production. Two parallel straightening units prepare steel and aluminum separately, letting the crew feed each material into the system without slowing anything down. The aluminum path first enters its dedicated feeding device, guiding the strip toward progressive stations where each punch step increases the accuracy of the form. The press uses link drive kinematics, giving the slide a motion profile that helps the tooling handle tougher geometries. This motion almost feels like the machine is thinking ahead, even though it's all mechanical timing. After the initial forming sequence, the transfer device is set. Y-axis travel reaches up to 125 millimeters, Z-axis up to 200 millimeters, and feeding strokes reach 700 millimeters, enough to move complex parts between stations. Each shift of the grippers moves the aluminum or steel blank into deeper forming, controlled by high dynamic movement. Steel parts follow a similar path but run through their own straightening equipment before entering progressive stamping. The wide slide and table, 4,000 x 1,800 millimeters, allow large tooling layouts, giving room for multiple forming stages. By the time the cycle ends, each stamped piece exits with consistent geometry. That final drop into the tray feels unexpectedly satisfying, finishing the sequence with a crisp, confident motion. Welcome to the Rotterdam site of Hendrik Vader Group, where heavy lifting comes alive. Watch as enormous coils of steel wire are transformed into powerful lifting slings. The scale of these coils shows how much material is needed for a single heavy lift cable. First, raw steel wires are drawn out and fed into a stranding machine, which spins them together into thick strands. You can see how each rotation adds strength as the wires lock tightly into place. Then those strands are bundled and twisted again to form heavy-duty wire rope, the kind used in cranes, bridges, and offshore rigs. Next comes quality control. Once approved, the finished cables are coiled and loaded onto heavy transport reels, ready for shipment. Finally, massive trucks or offshore vessels haul these reels, sometimes weighing several tons, off to construction sites or maritime projects. These cables are the backbone of any lifting or mooring operation. Hard not to react when you think about the forces these cables endure every day. Crazy to think a handful of wires ends up holding entire bridges or ships. The Heller F6000 is engineered to deliver strong cutting power, and its assembly reveals how that strength is built. The scale of the structure feels unreal at first glance. Work begins as the main base arrives and technicians position it to form the support for the machine's complex movements. The frame is aligned, tightened, and checked so future loads stay controlled. Kinda wild to see such a huge casting handled this smoothly. Next comes the column installation, where mounting points, rails, and interfaces are secured. Each segment is leveled, so motion stays true when the spindle travels across 5 axes. Cable routes and protective covers follow, forming a clean internal layout that keeps service access open. This tidy routing hits differently in a machine this big. The assembly continues with the spindle integration, one of the most important Heller-made components. Its housing, cooling, and drive connections are fitted to match cutting demands. A short test rotation confirms that everything moves with steady resistance. Hearing that first spin gives a tiny jolt of excitement. After that, axis drives and ball screws are mounted, allowing synchronized multi-axis travel. Panels, coolant modules, and tool change units complete the structure. Final checks confirm alignment, lubrication flow, and motion quality so the F6000 leaves the line ready for demanding machining environments. The whole build feels bold in the best way. The 10-year overhaul of Yukon Energy's Whitehorse hydro generator shows how uncommon full restoration work can be today. The team pulls the generator apart piece by piece, giving each component the attention needed to keep power steady for the region. Didn't expect the stator coils to look this clean after being lifted out. The opening tasks focus on isolating the generator housing and removing covers to reach the rotor assembly. Crews detach electrical links and secure lifting rigs to position the rotor for extraction. Once lifted, the rotor is moved to a work area for inspection, cleaning, and refinishing. That slow rotation before the hoist grabs, it almost feels like the machine sizing up the moment. Technicians check contact surfaces, measure clearances, and replace worn insulation so the unit can operate smoothly under heavy loads. Bearings are removed next, allowing the shaft to be examined and aligned. Further checks follow on the stator, including rewinding sections that show wear from years of constant torque. Feels like stored strength waiting to return once everything is reassembled. After these core parts are restored, the rotor is lowered back into place, electrical systems are reconnected, and balance tests confirm the generator can deliver output again. The final steps ensure the Whitehorse unit is ready for another decade of dependable service. Built to deliver a clean, consistent strike, each silver coin at the Northwest Territorial Mint follows a tight sequence that prepares the metal for its final form. That shine at the end always hits hard. Raw silver is heated until it becomes soft enough for extrusion. A hillet then moves through an extruder, forming a long strip with uniform thickness. That stretch looks wild, in the best way. Circular blanks are punched from the strip and placed on scales to verify proper weight. A few adjustments keep everything within range. Next, the blanks enter a burnished drum, polishing their surfaces for clean pressing. A die then stamps each design with firm pressure, locking details into the metal. That final strike feels powerful. Tight steel plates rely on steady guidance from the AK-YAP-AK Actdrill 1 APD 2000 by 6000 as each sheet moves toward accurate flange drilling. The machine directs the workflow without hesitation, and the smooth push feels unexpectedly bold for such heavy material. Marking comes first, with the arm tracing reference points that line up future drill paths. A quick glance at the markers almost feels like catching a tiny secret on the shop floor. Drilling follows as the spindle drops cleanly through the plate to form precise flange holes. The feed stays firm, and the sudden burst of chips looks almost playful for a job this serious. Multiple holes open across the surface while coolant steadies the cut, and the plate shifts into position for the next set. That rapid repositioning sparks a brief, "Whoa" moment. Chamfering wraps the sequence, shaving edges to remove burrs and smooth each opening. The cutter glides with an assertive sweep, and the sharp change in texture hits with a tiny thrill. Operators track the machine's pace while the table handles movement beneath the plate, and the quick transitions give off an oddly comedic bounce. The AKDRILL unit keeps output consistent as plates move in and out, ready for assembly lines that depend on uniform flange components. Overall output stays steady always. Using the generator repairs at Ethos Energy's Farmington facility as the setting, this introduction leans on the scale of work rather than technical jargon to pull viewers in. The rotor and stator arrive with years of wear, and crews move them toward inspection areas to map out what each section needs. Didn't expect the retaining ring surface to look this worn after the first check. The contrast between untouched sections and aged areas helps the crew decide repair priorities right away. The team lifts the rotor toward the balance line, where alignment tests guide the next repair steps. Stator bar manufacturing follows, supported by the facility in Lubliniak, Poland, where new conductors are formed for future rewinds. Back in Farmington, the bars slide into the stator core for rewinding, slot by slot, until the winding group settles into its layout. This stage can look unexpectedly intense, and the steady tension gives off a don't blink vibe. Rotor rewinds continue the sequence, replacing conductors and tightening connections to restore electrical strength. Machining steps come next as retaining rings and other parts reach required dimensions under CNC control. High-speed balancing follows, pushing rotors up to 150 RPM to stabilize performance. Final inspections close the process. confirming that each rebuilt rotor and stator can return to service with reliable output for demanding generator systems.